Hello, I am PIrwin. Today I'm going to show you how to determine the concentration of an unknown solution using Beer's law, Vernier LoggerPro, and a colorimeter sensor. Beer's law states the concentration of a chemical is directly proportional to the absorbance of the solution. I will show you how to plot the absorbance versus concentration for 5 prepared standard solutions of nickel 2 sulfate with 0.08, 0.16, 0.24, 0.32, and 0.40 molarities respectively using Vernier LoggerPro and a colorimeter sensor. Once the standard solutions have been plotted, we can add a best fit line and interpolate the concentration of an unknown after determining the absorbance using the colorimeter. The graph here shows the relationship I will be discussing with our live data collected. You can clearly see this straight line, which means it's a directly proportional relationship between absorbance and concentration, and we will be able to interpolate any point along the graph where our absorbance comes up for the concentration of the unknown. Our learning objectives in this experiment for today's video include the following. The student will use the colorimeter to measure the absorbance value of each nickel 2 sulfate standard solution, find the relationship between absorbance and concentration of the solution, and use the results of this experiment to determine the unknown concentration of another nickel 2 sulfate solution. As you can see here, I have already prepared the standard solutions and placed them into the cuvettes that will be placed into the colorimeter, and I've also prepared a 6th cuvette containing the unknown. Let's now look at the LoggerPro software with the Beer's Law laboratory experiment already open and ready to go.
The colorimeter has been calibrated so we can start to collect our data for the standard solutions. I'm going to click Collect and place the lowest concentration standard solution in the colorimeter, close the lid, and wait for the absorbance value that's displayed here in the lower left to stabilize. It will be stabilized once it stops moving, which is very rare, or fluctuating between a couple numbers in the thousandths place. It appears we have reached that point. So I'm going to press Keep, and since this is the lowest concentration, I'm going to enter in 0.08 moles per liter. That is the molarity, and I'm going to press the OK. All right. Now when I'm looking at my graph, I can clearly see that this first point is kind of high on the graph, so I'm going to change the y-axis settings. I'm going to click on the absorbance with the right key. I'm going to click on Graph Options. In this pop-up box, I'm going to click on the axes options, and I'm going to change the top of the range. I'm going to double the amount to 2.000, and hopefully this will fix it. If I need to change it again later after I get all the points in, I will do so then. Alright, so now I'm going to repeat those initial procedures. I'm going to take out the lowest concentration solution and put in the next one, close the colorimeter, wait for this absorbance here to stabilize. And once it appears that it has stopped moving or fluctuating in the thousandths place between a few points, which we have reached, I'm going to hit Keep. And for this one, I'm going to enter in 0.16, which was the molarity for the second solution. All right, so I'm going to continue on, and I'm going to do the third standard solution. Enter that in, wait for the absorbance to stabilize. Alrighty, looks like we've gotten there. Press Keep, and this one was 0.24 moles per liter, and I'm going to click OK. Alright, moving on to the fourth standard solution. I'm going to wait for this to stabilize. Alright. This one's a little bouncy. Alright, but it seems like it's got to a point where it's pretty much stabilized. And this one was 0.32 moles per liter. And then I'm going to do the fifth and final standard solution. Okay, looks like we've stabilized for that one too. And this one was 0.4 moles per liter. Okay, now that I've gotten all of those done, I can press Stop. And after I've pressed Stop, now we can actually analyze the data. So first I'm going to click on the linear button as I'm indicating here in the top toolbar. There's a whole bunch of different analyze functions here, but I'm going to click on the linear fit. And what appears here is a best fit linear regression line, and it's for the 5 data points of the standard solutions, and the line is passing through or near most of the data points on the origin of the graph here. To make this a little more visible for you, this box, the information in it, I'm going to right click and click on the linear fit options, and I'm going to change the appearance. I'm actually going to change the font size to something a little more legible to those watching this video, and I'm going to move this box out of the way of the graph. Okay, so we can clearly see what the slope is for this best fit line, and we can see what the y-intercept is, and we can see what the correlation is. The closer this is to 1, the better the fit is for the points on this graph. And then we have the root mean square error, and the closer this is to 0, it's also showing us how good of a fit this linear line is. All right, so the next thing I'm going to do is I'm going to interpolate the unknown solutions concentration. So I'm going to put it in the colorimeter right now. I'm going to wait for it to stabilize so we can actually see what the absorbance is for it. And I'm going to jot that down. All right, so it looks like it is fluctuating. And the middle point here, it looks to be 1.0686667. I'm going to go with 1.067, or a number as close as I can get to that. Right, so I don't need to take that out, but here is how we're going to interpolate that information. We are going to go to the Analyze, which is up here at the top toolbar. We're going to scroll down to Interpolate. All right, and there's a box that popped up, which just like the other one, I'm going to make this a little more legible. So I'm going to right click and I'm going to go to the Examine options. I'm going to change the font on this one to a much larger size as well. All right, so that we can read it. I'm going to move this box off the line as well. And you'll see that there is a vertical line that's now appearing that changes value, and it scrolls up and down along the best fit line here. All right, so what I'm looking for was that unknown absorbance, which was 1.067. So I'm going to scroll until I find a number as close as I can get to that. All right, 1.067, that looks like that's pretty good. And then the hard part is to bring your mouse straight up on that number until you get to the box, and then you can ease off because it's not going to change numbers as easily. All right, so now we can see what the concentration is, which the concentration of our unknown solution is 0.157, etc., etc., etc. moles per liter. All right, so now we can go and we can print our graph if we need to. So we can go to File in the toolbar, scroll down. We only want to print only the graph. You can enter your name in here if you'd like by clicking on the footer and entering your name. Whoops, let me fix that. You can add in a comment. Some people like to put in the title of the lab. All right, click OK. And if by chance students are doing this lab and they had multiple partners, in the next pop-up box you can change the number of copies. We're going to wait for that. This laptop is not currently hooked up to a printer, so it might be a little bit confused on that. And then you would click OK. So I hope this tutorial familiarized you with how to determine the concentration of an unknown solution using Beer's Law, a best fit line, and analysis through the interpolation with Vernier's LoggerPro and Colorimeter Sensor. And here we go. This is where you would change the number of copies. All right, I look forward to seeing you next time.